So we're looking at example problem 2. I have 2x squared equals negative 6x minus 7. Again, like I said, solving with quadratic formula, you do have to do it like factoring where it must be set equal to 0 in order to solve. So I am going to move that 6x and 7 over. So A is 2, B is 6, and C is 7. I do recommend writing that out. Some people don't need it, and that's cool too. Whatever floats your boat. So I have negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I'm actually going to go ahead and do is I'm actually just going to type all of this into my calculator. 6 squared minus 4 times 2 times 7. What I get there is a negative 20. So I have negative 6 plus or minus the square root of negative 20 all over 4. So we're going to go to the next page and take a peek. Plus or minus the square root of negative 20 all over 4. So with that negative 20, first of all, I know I'm taking out an I. Okay, I squared root of 20. And let's see what else I can take out. Looks like I can take out a 2. So I've got negative 6 plus or minus 2i square root of 5 all over 4. Okay, so this we ended up with a complex answer because I did have that negative inside the square root. So that's the other thing. I would never be able to solve this by factoring, especially if you get a complex equation. Okay, so now I'm going to see if I can factor out a GCF in the numerator, which I can. I can take out a 2. And then I'm left with negative 3 plus or minus I square root of 5 all over 4. I look here with 2 and 4. I can reduce it, so I'm good with keeping that factored out. 2 divided by 2 is 1, so I just have my 1. So I have negative 3 plus or minus I square root of 5 all over 4 divided by 2 is 2. So now that is simplified, so I am going to go ahead and separate my answers that x is negative 3 plus I square root of 5. Oh, that was a really gross 5. Hang on. I square root of 5 all over 2. And negative 3 minus I square root of 5 over 2. So nothing different with the quadratic formula. I just wanted to show you what happened if you had a complex answer. Okay, so don't be surprised if you see that in your work. One final one looking at quadratic formula before we do a different kind of example. So I have negative x squared minus 8x plus 4 equals 0. With example 1, I mentioned, well, what happens if your a is negative? And here we see that. So that's why I wanted to just take a peek at an example when that happens. And I also wanted to take a peek at an example of when b is negative as well. So we have the opposite of b plus or minus the square root of b squared. One big thing is, whenever you substitute, it is crucial that you put it into parentheses, okay? Mainly because if you type in negative 8 squared like that, or negative 8 squared into your calculator with parentheses, you get two different answers. So it's very important that you have that negative 8 is b. So that must be noted, I guess you could say, not notified, but noted. So I have minus 4ac all over 2a. Okay, so the opposite of negative 8 is a positive 8. Plus or minus, and I'm going to go through the motions and do negative 8 squared minus 4 times negative 1 times 4, and I get 80 all over 2 times negative 1, which is negative 2. Okay, so let's see if I can break up that 80. I can do 16 and 5, 4 and 4. I'm not going to break that down anymore. I've got the 4s that I can take out, so I'm going to take out that 4. So I get 8 plus or minus 4 square root of 5 all over negative 2. Okay, so looking here, first what I'm going to do, let me move on to that next page where I have 8 plus or minus 4 square root of 5 all over negative 2. This 5, it keeps looking really funky. I'm going to go ahead and see if I can factor out a GCF in the numerator, which I can. I can actually factor out a 4. Okay, so I have 4, and then I've got 2 plus or minus the, let's see, that's just going to be a 1 square root of 5 all over negative 2. So looking at 4 and negative 2, I can divide them both by 2. Okay, so I end up getting 2 times the quantity of 2 plus or minus square root of 5 all over negative 1. You do have to have that negative 1 in the denominator. We're going to handle that here in just a moment. But this is a situation here where this, while it might seem simplified with that 2 factored out, it's actually not really the ideal looking answer, okay? So I did factor out my GCF, I did reduce. Now that I've reduced and I've got something left over in the numerator, which we haven't seen yet, I'm going to redistribute it, okay? So I end up getting 4 plus or minus 2 square root of 5 all over negative 1. So you can kind of have that foresight of, oh, I've got negative 2 in the denominator, so I'm only going to factor out a 2, not necessarily the GCF, but a common factor. You can look at it that way, or you could just factor out the GCF, see what you can reduce, and then redistribute if necessary. So now what I'm going to do is I'm going to separate 4 plus 2 square root of 5 all over negative 1 and 4 minus 2 square root of 5 all over negative 1. Now what I'm going to do is basically I'm going to divide my whole numerator by negative 1. Okay, so now what happens is that I get when I divide by negative 1, this becomes negative, this becomes negative, and that becomes a positive 1. And then this becomes negative, that becomes positive, and this becomes positive. So now my answer ends up being x equals negative 4 minus 2 square root of 5 and negative 4 plus 2 square root of 5. So that's what happens anytime a is a negative number. So you're going to, when you actually write it separately, that's when you're going to actually see that. Okay? And I have one more kind of problem. It's similar to the earlier lesson where we have to write the equation in standard form with the given solution. Okay, so let's take a peek. So what I've got here is negative 3 plus I square root of 11 all over 2 and negative 3 minus I square root of 11 all over 2. So the big thing is you need to know what A, B, and C are. And once you know A, B, and C, you can easily figure out the actual quadratic equation in standard form. Well, I know that B is going to be positive 3 because you always have to remember what the quadratic formula is, and it starts out with the opposite of B. Okay, so that's pretty easy. Also, I can figure out A because my denominator is 2A. So I'm going to do 2A equals 2. Well, if I divide by 2, A just equals 1. Okay? So far, so good. Now, the other thing that I need to look at is whatever has been taken out, I need to square it and multiply it by what I've got inside. Okay, so it's like undoing that process. So I'm going to square I. So I'm going to get I squared, which I know is negative 1. And I'm going to multiply it by the innards. So negative 1 times 11 is negative 11. So really what was in there was the square root of negative 11. Okay, so that means B squared minus 4AC has to end up getting negative 11. Okay, so B squared minus 4AC has to end up equaling negative 11 because that's what I ended up, that's what I would have had inside of that. Okay, and so then what I'm going to do, I know B is 3 and I know A is 1. So let me just I'm just going to kind of erase this stuff here that I've got going on so that way I can utilize this space and not have to flip it to a new page. Okay, so I know B is 3, I know A is 1, and really I just need to figure out what C is. So 3 squared is 9 minus 4C, because negative 4 times 1 times C gives you negative 4C, and that equals negative 11. I'm going to subtract 9. So now I get negative 4C equals negative 20. And now I'm going to divide by negative 4. So C gets me 5. So now that I know what A, B, and C are, I can write my quadratic equation. So A is 1, so I'm going to have 1x squared. So really, I'm just going to go ahead and write that as x squared. C was 3, so it's going to be plus 3x. What did I just say? C was 3. Oh, Lord have mercy. B was 3, so I'm going to have plus 3x. And C was 5, so I'm going to have plus 5. Now, if any of these were negative values, which this just didn't happen to be, then it'd be minus those numbers there. And that then gets me my quadratic equation in standard form. So this wraps up the solving quadratic equations using the quadratic formula.